Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the circumference and perimeter as well as area of circles and sectors. So let's look at this circle here. We'll start by calculating its circumference. So the formula for circumference are here, diameter times pi or 2 times pi times radius. Obviously use this one if given the radius, this one if given the diameter. Here we're given the radius is 2. So the circumference is 2 times pi times radius, and you can put that straight on your calculator. To 2 decimal points we get 12.57, and obviously it's centimeters because the radius was given in centimeters. To find the area of this circle, it's pi times radius squared, pi times 2 squared, which gives us the same number, 12.57, but the units are in centimeters squared. All right, let's calculate the circumference and area of this circle here. So this time we're given the diameter. So the circumference is just going to be the diameter times pi. So to 2 decimal places we get about 31.42. And of course, measurement will be in meters. The area of this circle is just pi times radius squared. So putting that in our calculator again to 2 decimal places, we get 78.54, and it'll be meters squared. So circles are pretty easy, but now let's look at the area and perimeter of sectors. So a sector is a part of a circle. So let's calculate the area and perimeter of this sector here, this little slice of a circle. So we're going to sort of use the same formula as we did on the previous slides, but we're just going to do one thing different. So let's say I wanted to find the perimeter of this shape, the length around the outside. Well, I need to start by finding this, which is the arc length, this curved surface here. So what I'm going to do is I'm going to calculate the circumference as if this were like a full circle. So the circumference of the full circle would be 2 times pi times radius. So that gives me the length around the outside of the circle here. But of course, this part is what I'm interested in, and this is certainly not a full circle. So what am I going to do to account for that? Well, this angle here is 40 degrees, whereas, in a whole circle, the whole way around is 360 degrees. So this 40-degree angle tells me what fraction of a circle I have. See, 40 over 360 is 1/9. This is 1/9 of the circumference. So what I'm going to do is I'm going to take my circumference and times it by this number here, 1/9. That is the arc length. But that only gives me this length here. I also need to add 7 and 7 again to get the full perimeter. So the whole perimeter of this shape here is the arc length, which is this bit here, plus the 2 straight edges. So that gives us the formula for the perimeter of a sector. Theta over 360, theta is the angle in the middle. That tells you what fraction of the circle you have, times 2 pi r. That gives you the arc length, and then you need to add 2 lots of the straight edge like we did here. That's the formula I could have used to get this number here. So this is the perimeter of the whole sector. So all I need to do now is put that in my calculator, and to 2 decimal places I get about 18.89, and of course it's in centimeters. So a big mistake people make when they're calculating this is they forget to add these straight edges. But now that I've told you, you won't forget. So let's calculate the area of this sector. So we're looking at the area inside here, this little slice. So what we're going to do is, again, calculate the area of the full circle. So the area of the full circle is pi times radius squared. But once again, we're going to account that this is only a fraction of a circle. It is 1/9 or 40 over 360. So I'm going to take the area of the full circle and times it by 1/9. I'm finding 1/9 of the area of the full circle. And so if I put that on my calculator, I get about 17.1 and of course it'll be centimeters squared. So to find the area of a sector, you just take the area of the whole circle and you times by theta over 360. So area of the full circle times the fraction of the circle you have. We can just use those formula. So let's look at this sector here. So of course, if this here is 90 degrees, this angle here will be 270 degrees. See, this is 270 over 360, which is 3/4 of a full circle. So, using the formula above, the perimeter of this shape is theta over 360, 270 over 360, or you can use 3/4 if you like. Theta over 360 times 2 pi r plus 2 straight edges. Once again, a lot of people forget to add these 2 edges here in the perimeter. So putting that in a calculator, we get about 60.41 meters. So let's now calculate the area of this shape. So the area of the full circle is pi times radius squared, and we just times that by theta over 360. We times it by 3/4 because it's 3/4 of a circle. So putting that on a calculator, we should get about 190.85 meters squared. So you need to add in these straight edges when finding the perimeter, but note I didn't do it when finding the area. All right, let's take a quick look at finding the radius if I know the area of a circle or sector. So let's look at this question here. What is the radius of a circle with area 32 centimeters squared? Well, I know the area of any circle is pi times radius squared. So I know pi times radius squared is equal to 32. All I need to do is get r by itself. So what I'm going to do is divide each side by pi. Pi is just a number, even though it's a very complicated number. And then to get r by itself, I'm going to square root 32 over pi. If you put that in your calculator, you get about 3.2 centimeters. So that is the radius. So let's now find theta, this angle here, if the area of this sector is 14.14 centimeters squared. Well, we know for a sector, the way we'd find its area, we'd go theta over 360 times pi times radius squared. And that gives us our area of 14.14. So I need to get theta by itself. So what I'm going to first do is undo dividing by 360 by timesing by 360. So I get on this side 5090.4. So to find what theta is, it's just being times by pi times 6 squared. So all I need to do is divide each side by that. Theta will just be 5090.4 divided by pi times 6 squared, and I can put that straight on my calculator. And the answer I get is about 45 degrees. So this is about 1/8. 45 over 360 is 1/8, about 1/8 of a circle. Theta is 45 degrees. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.